Lesson 27, permutations with repetitions and restrictions. All right, so we actually kind of dealt with some of these things in the last lesson, so some will be review, but yeah, with restrictions especially, right? So we'll do some more examples of that below. Repetitions, though, this will be new. So if we take some of the examples that we did like in the last lesson there, right? Where if we consider the word pool, okay, and we say, okay, well, how many ways can we arrange that? Right? So if we had, four blanks, right? Then typically the way we would do that is we'd say, okay, well, there's four letters. So we go four, and then there's only three, two, and then one, right? So that's typically how we would handle that. But the problem with that is that you've got two O's, and the O's are what are called like indistinguishable objects, right? They're indistinguishable or identical, which means it doesn't matter which one I have there, right? So I can actually make less words out of this, right? And you can think about it this way: if we rearrange it as like POOL, well, you could flip those two O's around, but we only actually have it's still the same word, right? So we need a way of like canceling really all the bottom versions to figure this one out, right? So this is where repetitions is going to come in. So the way this works is by the general equation, n factorial over, and then the a, b, and c stands for the repeats. So let's say, like in our example above, the way we could figure this one out without writing all the different examples out like that is we could have said, okay, there are four letters altogether, so 4 factorial over, and then the O's repeat. So there's two of them, right? So then it'd be divided by 2 factorial. Which, remember, 2 factorial is really just 2, right? Because it's 2 times 1. Okay, so then we could say, okay, let's practice expanding this out. This would be 4 times 3 times 2 times 1. And the bottom would be 2 times 1. So really, this is all the same thing as just 4 times 3. So this is 12. All right, there's 12 different ways that we can do this. All right. I'm going to explain, a bit more of that below, though, too. We're going to have some examples of that one. So actually, this first part, we're going to do some restriction stuff, okay? So this first example says, how many arrangements are there with the word Friday when the vowels stay together and at the beginning? All right, so let's make our spaces again. So we got 6 different spaces there. And it's saying that, yeah, the vowels have to be at the beginning. So, all right, let's think about it this way. So we could have I in that spot, and we could have A in that spot, right? And if you think about it, how many ways are there to have that situation? Well, there's only one way, right? But here, just kind of bear with me. So we could have like the I in that spot, the A in that spot. Here, you know what? I'll write those below so we can put the numbers in. So it's like we've got A there, or I there, sorry. We've got A there. One way for that to happen, one way for that to happen. And then now that we've handled all that, we've handled those restrictions and they're at the beginning, well, then we could say, all right, now we've got 4, 3, 2, 1, right? Like everything else. But now you're probably saying, yeah, but that wasn't the question, was it? It said that they just had to be together. They didn't have to be together this way, right? So we could have also written it like, well, with the A first and the I second, and then you'd have, well, one way for that to happen, one way for that to happen, and then we'd have our blanks again, 4, 3, 2, and 1. Now, this is an or situation, so it's this situation or this situation. So really all we're going to do here is we just add them up, right? So in this case, this was, equal to 4 factorial, and this was equal to 4 factorial. Okay, so then in the end, this was 48. Okay, so that's one way of doing it. That's one way of thinking about it. I'm going to show you guys like one more way that I think I typically do. I just want to kind of see why this would work, right? That maybe that's a good way of thinking about it. Let's do this again. Let's make our spaces. All right, and again, we'll put our blanks there. You could do it this way too, and actually say, okay, let's just focus in on this first spot, right? Well, that is, well, there's 2 that could go in the first one, and then one that could go in the second one, right? And that's me just saying it could be an I or it could be an A, right? So in the first spot, that could be an A or an I, and then you got one after that. And then when we're done this, then we just have to focus on the rest. So then after that, we've got 4 times 3 times 2 times 1. And this would also do it, right? Because this is really 2, well, 2 factorial, if you like, doesn't really matter, times 4 factorial. And that's the same thing as, oh, I should have added those, 4 factorial plus 4 factorial, right? So in the end, either way, that's 48. I think I typically like this way better, but either way, I kind of want to just play around with that so you kind of see that we end up getting the same things there. Okay, next one. How many arrangements are there with the word oranges? Okay, and the letters G, E, and S must stay together, but are in no particular order. So first off, there is no repeats. I know we haven't really gone through that much yet, but there's no repeats yet. So we're going to just treat it like before. But let's do this. So what we're going to do is we're going to make our blanks. How many words are there? Just, yeah, same as before, I think, right? So, okay. And then I'm just going to put brackets around this first part. This one does say in no particular order, but they must be together. So what we're going to do here, let's just focus in on this one for a second. So I'm just looking here, right? So these were my letters G, E, and S, right? And they could be in any one of those. They could, like, they could be in whatever order they want there, right? So let's just focus on that first. So if I'm looking at that group of them, well, in this first spot, there could be 3. And that could be a G, and an E, or an S. In the second spot, there's only 2 now, and then 1, right? Same as before. But now here's what the difference is going to be. So in this question, we can imagine this group, right, as being like another thing that's able to move. It's like it's another blank now, right? Because this group could be, here, I'll just draw it. You don't have to draw this, but it could look like this. It could be, one blank, and then our group of 3, 2, 1, right? And then 3 more blanks, right? You kind of see that like this group of them could move over to that spot or to that spot or to that spot. So the 3 of these are acting like another blank themselves, right? So what I'm going to do now is I'm going to actually just consider this a blank, right? You can write it above it or below it. I usually write it above it, but I'm out of room here. And then this would be, well, there are 1, 2, 3, 4, 5 spots. So this would be 5, 4, 3, 2, and 1, right? So in the end, this is just going to be 3 factorial times 5 factorial, which is equal to 720. Okay. Hopefully that made sense. I know it's a little weird, right? So the 3 factorial was for these guys. The 5 factorial was for the 5 letter chunks you could think of. Okay. All right. Next one. So now it says the consonants must stay together. Okay. So consonants must stay together. How many consonants do I have? 1, 2, 3, 4. Right. So it's really going to be the same situation here, right? So let's write all our blanks. So we've got 1, 2, 3, 4. All right, so now we're going to do the same thing, but with consonants here. And yeah, so there's 4 of those to choose from. So we're going to have 4, 3, 2, 1, right? Those are my consonants. And then again, I'm going to treat this like it's its own little blank here, because this group itself can move. So then this is going to be, well, there's 4 left. So 4, 3, 2, 1. So this would be the same thing as 4 factorial times 4 factorial, which is equal to 576. Okay, next one. So how many different 8-letter arrangements can you make using the letters of Aardvark? All right, these ones actually are pretty straightforward and easy. This is looking up to this example here, right? This is our general way to do these ones. So if we didn't have any repeats going on in this word, then all we would do is we'd just count all the letters, right? So, and not even just count them all, right? So it'd be 1, 2, 3, 4, 5, 6, 7, and there's 8, right? So if there was no repeats and they were all different letters, that would just be 8 factorial, and I'd be done, right? 8 factorial. But now we've got some repeats. So the way that we get rid of the repeats, right? So it is just by dividing by the repeats. So we've got 3 A's. So there's got to be a 3 factorial down there. Do we have anything else? We've got 2 R's, right? So then it's going to be 2 factorial. And you can imagine, right, if I expanded the top and expanded the bottom, what we're really doing here is this 3 factorial is just getting rid of all the repeats, right? It's canceling the repeats of the A's. And the 2 factorial is getting rid of the repeats of the R's, right? It's just not counting them because they're the same. Okay, so then, yeah, that's it. So then that's just going to be equal to 3,360. Okay, and then Mississippi. Well, if you count all the letters, you get, there's 11 of them. And then dividing by the repeats, there are 4 I's, so 4 factorial. There are 4 S's, so 4 factorial. And there are 2 P's, so 2 factorial. So there are 34,650. All right, so now this is actually the same concept, but it's just kind of a specific skill here, I guess, with the pictures. It's a very common type of question in 30-1 and 30-2. So this one says, consider a town with streets and avenues at right angles to each other. How many paths can you follow from corner to corner of the town to the other from A to B if you always move closer to your destination? Okay, so what they're saying here is that we start at A and we want to get to B, and that means that I could go this way and up, and then, you know, I could go like 2 that way and up, and like 3 that way, and then something like that, right? I could take a path like that one. What I can't do is go this way, up, and then back, and then this way. It says I'm always getting closer to my destination, right? So I have to either go to the right or up. That's pretty much it, right? I can't do anything else. Okay, so if that's the case, then what you can see we got going on here, right, is it's really the same question where one spot to the left, I'm going to call that east, right? So we got east, and then another east, another east. We got a bunch of E's there, right? And then from there you've got N, right? So why I wrote that, right? Like, this isn't necessarily the path they took, but if you think about it, no matter what path I trace through here, right, it doesn't really matter. No matter what I do, if you count them, right, if we just count these, I've got, there is an east, 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 and east, right? So how many are there? You've got 6, right? You've got 6 easts, no matter what way you take. So that is always going to be the case, right? And then the same thing for the norths. It doesn't matter what path I take through this thing, right? That if I go like this way, oh, not like that, whatever happened there. This way, up, that way, up, and then over. Same thing with the norths, right? I've got 2 norths and 2 norths. So I got 4 norths, no matter what path I take, right? So in the end here, I have, well, there is going to be 10 different like ways I'm going to go, right? If I count them all up, right? These 6 and these 4, no matter what path I take, I'm going to have 10, right? So I'm going to have 10 different paths. So I can say 10 factorial. And then what I'm going to do is I'm actually just going to divide by the repeats. Can you guys see that the E's are all repeats, right? They're all exactly the same. This is like the same concept as having all the same letters. So if I want the number of ways, I'm going to go 10 factorial. And I'm going to divide by, in this case, 6 factorial, because there's 6 E's, and then 4 factorial, because there's 4 norths. And that should give me my answer. So that is 210. Just to hammer this home too, and just show you that is the same thing. Why don't we write this out like it was like a letter, right? Like one map through this thing would have been saying, okay, we're going to go east, 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 and east. And then we're going to go north, 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 and north. So this is kind of like the same as the questions we had above, right, with the words. Let's pretend that was our word, and we had this many repeats. Well, we'd do the exact same thing, wouldn't we? We'd say, okay, of the 10 letters, we're going to divide by, well, there's 6 E's and 4 N's. So it'd be like the same question, right? Because we could rearrange these in any order. It could be east, north, east, east, so and so on, right? Like we have all those different variations that we could do. Okay? All right, hope that makes sense. Okay, now when it has a little break in the middle here, it's actually still kind of the same question. We just have 2 of them, right? So now they're saying we're starting at A going to B, right? So we're starting here and we're going to here. So in this case, in order to go from A to B, I've got to end in the middle here at some point, right? So let's just do this first block. If you think about it, we've got 1, 2, 3, 4 easts, right? So here I'm going to draw an arrow and be like, okay, we got 4 easts that we got to have. And then we've got 4 souths. So let's do that first block. I've got 8 in total, right? No matter what I do in that first block, I've got 8 factorial. And then I've got to divide by the repeats. So that'd be 4 factorial times 4 factorial in the bottom. Okay, so that's the number of ways to get to here. And then if I figure out the number of ways from this spot to this spot, well, there's going to be 4 easts and then 2 souths. So that would be, okay, there's going to be 6 total possibilities, right? 4 plus 2. And then there's going to be the repeats. So then 4 factorial and then 2 factorial. Now, what do we do with these 2 numbers? Because these are just numbers, right? Like that's a number and that's a number. Well, in this case, if you think about it, this is an and situation. Because we're going to go from A to here, so it's this and this, right? They both need to happen. Now, if these blocks weren't connected, if they just said like how many possible ways are there of like this block and this or this block, then we would add them, right? But since it's an and situation, we multiply. This is that whole like if you have 4 different shirts and 3 different pants, how many different outfits can you wear, right? Well, that'd be your shirts, the number of ways for your shirts and the number of ways for your pants. This is the same thing, right? So we multiply those situations. Oh, I never gave you the answer. Okay, so then the answer here would be, that would end up being 70 for the first way times 15 for the second way, which is equal to 1,050. All right. How many ways can 1 French poster, 2 mathematics posters, and 3 science posters be arranged in a row on a wall if the 2 mathematics posters must be together on the end? So this is really stuff that we've done before too, right? The same idea-ish from above anyway. All right, so the 2 mathematics posters must be on. So let's write out our blanks though. So we've got 6 blanks, right? Because we've got our 1 French poster, 2 math, and 3 science. We've got 6 in total here. Now, on the end here, we have to have our mathematics posters, right? So with the mathematics posters, there's 2 of them. Okay, so in this first spot, there could be 2 situations, or 2 options, and then 1. Okay, and these guys have to be on the end too. So this isn't like the situation up above where I made this thing its own blank, right? This one has to be here. So that's it. I'm just going to leave it just like that. But then I'm just going to look over here and just fill in the rest, right? So then once we're done with those 2 those 2 posters, then we've got 4 to choose from, and then 3, and then 2, and then 1. So in the end here, this is really just 4 factorial times 2 factorial. Or while we're at it, let's kind of get good with the permutation notation there. This would be the same thing as of the 4 posters, of these 4, we're going to pick 4 of them and multiply that by of these 2 posters, we're going to pick 2 of them, right? Which is, you guys see how those are the same? Factorials and then a permutation with all 4 or with everything in it, they end up being exactly the same, right? Okay, The three science posters must be together. We've done one like this above, right? So again, let's make our blanks. So our science posters have to be together. So, okay, and there's three of them, so it'll be 3 times 2 times 1. And then this is the situation, though, where this group of 3 could move, right? This thing could move as well, right? It's like it's its own little block now. So I'm going to put it above it as, okay, now 4 times 3 times 2 times 1. So this is really the same as 3 factorial times 4 factorial. All right, the three science posters cannot all be together. All right, so at first glance, this one seems like it's going to be really confusing, right? Like there's a lot of options here, and like you could actually do it where you had a bunch of or scenarios. So it could be like this, or this, or this, or this. But I tell you, it's going to be a lot easier if you guys use this method here. So this is an indirect method, it's called. And the way we're going to do it is we are going to say, okay, well, if we want the ones that cannot be together, three posters cannot be together, why don't we just take the total, right? And then subtract the posters together. Sorry, my pen's going along here. Right? So we're going to take the total and then subtract our posters actually together, right? So what would the total be? Well, the total would just be if I didn't care what kind of posters they were at all, right? So if that was the case, then there's just 6 posters. And then, well, if you were going to draw the blanks, it would be 6, 5, 4, 3, 2, 1, right? Well, that's just 6 factorial. So it's going to be 6 factorial is my total, minus, and then the posters together. Well, that was what we just did up here, right? And, oh, I didn't write down what that number was. Sorry, guys. That was 144. So there was 144 for the last one there. So this would be 6 factorial minus the posters together, which is 144. Okay, so that ends up being 576. Okay, so put a star on that. This one comes up quite a bit. It's because it's like another layer of thinking there. So whenever you guys see that they cannot be together, you should be thinking, okay, how many ways are they together? And then take your total minus that to get the other situation. All right, a couple tricky ones for the end here. So this one says, how many 4-digit odd numbers can you make using the digits 1 to 7 if the numbers must be less than 6,000 and no digits are repeated? All right, there's a lot of restrictions happening there, right? Let's make our spaces. So 4 digits. Okay, so let's make 4 blanks. Let's figure out just piece by piece what we're dealing with here. So it says it's got to be less than 6,000, right? Well, that kind of puts a restriction on our front number, right? So write this, like actually write it down just to kind of get your feet under you when you're doing these. So then you could say, okay, if it's less than 6,000, then the only options here for my first number are going to be 1, 2, 3, 4, and 5. Notice that I didn't put 0 there, right? Because that wouldn't be considered a 4-digit number, right? If it was 0, 3, 5, 7, right? That's not a 4-digit number. That's a 3-digit number. So the first one can't be 0. So those are the ones I have to deal with, right? And now the other part of this is that the backside has to be odd, right? So the last number here has to be an odd, make it an odd number. So what do we have to make it odd? Well, it could be 1, 3, 5, or 7. Now, when you're looking at this, just kind of play around with it for a second too, to kind of test things out. We're going to run into an issue where we can't just throw our numbers in because, well, if we think about this one, right? If I threw like a 1 into that last number, right? Then doesn't that affect the number that I can put in at the beginning, right? Because they can't repeat. So I can't put a 1 in at the beginning, right? So that would affect that one. So I can't do that. So we'll have to make a situation for that. But then the other part, well, I'm sorry, and that would be the same for 1, 3, and 5, right? If I threw a 3 in there, then now I can't throw a 3 in for the beginning. And if I threw a 5 in, now I can't throw a 5 in at the beginning. Okay, so there's going to be some restrictions on that. But then here's where we have to make a distinction, because if I throw a 7 in there, that's fine. That didn't affect any of the numbers I could throw in for the first one. So we actually have to handle these differently. We've got two situations. So here, we are going to make one situation. We're going to make, well, two situations in the end here. So I'm going to draw my blanks again. So here's our first situation. Okay, where this one will be if the last number is 7, right? Because like I said, if I threw a 7 in there, that doesn't affect this. Okay, so in that situation, here, let's write that down too. So we'll put like a 7 in this spot. 7 in last spot. Okay, so in this case, well, if the 7 is in the last spot, how many ways can that happen? Well, just one. The 7 is in that spot, right? And then let's go back over here and say, okay, at the beginning here, if they're the numbers 1 to 7, then what did I have to choose from? Well, it was these numbers, right? 1, 2, 3, 4, or 5. So we've got 5 options there. Okay, now let's think about the next spot though. So the next spot could have been, like, these ones were restricted, right? They had to be the numbers 1 to 5. This next spot could be the numbers 1 to 7, right? But not completely. I've already chose the 7 to go in there, and I've chosen one of these numbers to go in there. So I've actually only got 5 left, right? I've only got 5 left for that spot. Well, hopefully that makes sense, right? Just these take a lot of practice, right? Just kind of working through these. And then now from that point, it kind of all makes sense. So you're like, okay, so now I got 5, and then you've got 4. And if we had like more digits here, then the next one would be 3, 2, like you keep counting down, right? But that's kind of the hard part. So you got to like set this one up, see how that one affects this one, see how that one affects that one, right? Okay, so that's our option number 1, right? That's our situation number 1. So that's going to be equal to 100 different ways that could happen. And then let's look at the next one. So in the next one, we're going to say not 7 in the last spot. All right, so now in this case, we'll say, okay, well, if it's not 7 in the last spot, then I've got 3 to choose from. So it's going to be 3, right? All right, but now, if I've chosen 1, 3, or 5 for this last spot here, right? Let's say I chose 3. Then now 3 is off the table, and I can't choose it, right? So how many do I have left? Well, I'm only going to have 4. So now this is 4 for that one, because I've chosen one of the ones on the end there. Okay, and then same logic as the last one now. So if I'm looking at this second spot, then if I have 7 to choose from, and I've chosen, a number to go there, a number to go there, then I only have 5 left to choose from for that one. And then you're going to have 4 from there. Okay, so if you multiply those together, we end up getting 240. And then what do we do with those two numbers? Well, this really is a or situation, right? So it was this situation or this situation, right? It's not and. It wasn't both those things happening, right? Only one of them is going to happen. So it's an or. So we're going to add those two together. So if you add those two together, we end up getting 340. Yeah. All right. Practice with that one. Okay, another one. And sorry, guys, I think I made a goof there too. I was kind of telling you about the front one can't be 0, but it never could be 0 anyway because the digits were only 1 to 7. So sorry if that confused you there. Okay, because in the next example, then that won't be the case. So this one says, how many even 5-digit numbers are there? Okay, so that's the whole question. But then they're just saying, remember, yeah, that the front one can't be 0, right? Okay, so let's draw our blanks. So we've got 1, 2, 3, 4, 5. And to get our bearings again here, let's write down the numbers that we're allowed to have. So the only restriction here is that, well, there's two, but that one can't be 0. Right, so that cannot equal 0. And then this one is even. Right, it just means the number has to be even there. So our numbers that could possibly go in there would be 0, 2, 4, 6, and 8. Right? But then again, we start kind of playing around with this, and you realize that there's a little issue, right? Where, what if I threw 0 into this? Well, actually, you know what? What if I threw I'll show you one of the other numbers first. What if I threw like 2 into this? Okay. So if we play around with that, we're like, okay, so if a 2 is in there, then what does that do to my beginning number? Well, there's 10 to choose from originally. It can't be 0. And then it can't be the one I chose here. So then there would only be 8, right? To begin with on that one. Okay, so that'd be fine, but like I said, now what if we throw 0 in there? This will be like a different scenario, because if I throw 0 in there, and then I say, okay, what will my front number be? Well, there's 10 to choose from. It can't be 0, and if I chose 0, then it's not going to be 0 anyway, right? So then there's 9. So I got two situations here, right? I got the situation where we've got our last number is 0, and then I've got the situation where our last number is 2, 4, 6, or 8. Okay, so we're just going to split it up again. We're going to have like the OR situation again. So situation 1 and situation 2 here. So situation 1 is going to be when we have 0 in the last spot, right? We'll just do that one first. So if we have 0 in the last spot, then okay, there's one way for that to happen. And then, like I said, then there's 9 for the first one, right? Because that last one doesn't even affect the first one because it can't be 0 anyway. So yeah, we can write down can't be 0. And then from there, well, from there we're pretty good now, right? Because we've chosen 1 for that last spot. We've chosen 0, and then we've chosen some other numbers. So then, really, then there's only 8 to choose from, and then 7, and then 6. Okay, so there's situation number 1. So situation number 2 is going to be, well, if we had 2, 4, 6, or 8 in that last spot, right? So any of those. All right, so if we did that, then we'll just be careful here. So how many options are there? Well, there's 4, right? It could be any of those numbers. And then after I've chosen one of those numbers, if I look to the beginning here, well, it can't be 0, so okay, it's not 10, so 9. But then now I've chosen one of these, so now it's 8. All right, so I kind of did that one before as well. And then same situation as above for the next number here. I chose that last number. I chose that front number. So now there's only 8 left to choose from. And that's easy from here. And then it's just 7, 6. There's 7. Oh yeah, 7, 6. And we're done. Yeah. So then that's it. So we will multiply those all together. For the top one, we get 3,024. For the bottom one, we get 10,752. And then, like I said, this is an OR situation, so we're going to add. So adding those two together, we get 13,776.